Thank you for joining this lesson. We are going to look at area approximation using the mid-ordinate rule. We are given a question here whereby we are told in number 19 that the velocity v in meters per second of a vehicle at any time t seconds is given by the equation v equals to t squared minus 4t plus 5. Then we are told to first of all complete the table below. A table of t and velocity v. When the value of time is 1 second, the velocity is 2 meters per second. Therefore, we can now use the equation here to fill the missing gaps. I can see the value of velocity at t equals to 3 is given as 2. At 4, it is 5. At 6, it is 17. So we can fill the other blank spaces now, whereby we're going to substitute the value of 1.5 in the place of time, such that 1.5 squared minus 4 into 1.5, then plus 5. 1.5 squared minus 4 into brackets 1.5, then plus 5. This is giving us 1.25. 1.25. Therefore, we start with v equals to 2, then we go to 1.25. When t equals to 2, we start with 2 squared minus 4 into 2, then plus 5, and this gives us exactly 1. Then at 2.5 squared minus 4 into 2.5 plus 5. This gives us 1.25. 1.25. At 3, the value is already fixed. So at 3.5 squared minus 4 into 3.5 plus 5. This gives us 3.25. 3.25. At 4, the value is 5. At 4.5 squared minus 4 into 4.5, then plus 5. This gives us 7.25. Then we have at 5 squared minus 4 into 5 plus 5. This is exactly 10. Then at 5.5 squared minus 4 into 5.5, then plus 5. This gives us 13.25. At 6, we have 17. But at 6.5, we square it, minus 4 into 6.5, then plus 5. This is 21.25. 21.25. At 7, we square 7, then minus 4 into 7, plus 5. This gives us exactly 26. Then we go to 7.5 squared minus 4 into 7.5, then plus 5. This is 31.25. 31.25. And finally, 8 squared minus 4 into 8 plus 5. This is exactly 37. Exactly 37. So that is the table, which is part A of the equation. Part B, we are told, use the mid-ordinate rule with 7 strips to estimate the area of, or the area enclosed by the curve v equals to t squared minus 4t plus 5. The t-axis and the lines t equals to 1 and t equals to 8. So in case we had the area sketched, just a sketch of the area enclosed, such that we have velocity here and time here, time t. Then we would have the values of velocity from 2 up to the highest value of velocity, which is 37. Say that 7 is here. Then time is ranging from 1 up to 8. From 1 up to 8. Therefore, this curve is going to move such that from 1 up to 8, there is area enclosed by the curve, the t-axis, and the lines t equals to 1 and t equals to 8. Therefore, we are told to use 7 strips. And to use 7 strips, then we will divide this area from 1 to 2 to 3 to 4 to 5 to 6 and 7. Therefore, these are 7 strips. 1, 2, 3, 4, 5, 6, 7. So the strips are 7. Now that the strips are 7 and we are told to use the mid-ordinate rule, then we are going to use the values of t at the mid of each strip, such that from 1 to 2, that is the first strip, whereby the value of t is 1.2, 1.5 at the center. So now we value the height of this strip, which is at the center. So we have the strip and we have the first height and the last height in the strip, but now we are concerned with the height of the strip, which is at the mid, because we are using the mid-ordinate rule. Therefore, we use the values of v when t is 1.5, and again for the second strip, whereby t at the center is 2.5, then we use the value of v at the center when t is 2.5. When t is 3.5, we consider the value of v. So in simpler terms, we are getting the heights of these strips at the mid of each strip. Therefore, the mid-ordinate rule gives us area following the formula where we have the interval of the strip, then multiplied by the sum of the mid-ordinates. The sum of the mid-ordinates, such that now in this case we shall get the interval of the strip from one strip, or what is the width of each strip. So from 1 to 2 we have only 1 unit, from 2 to 3 only 1 unit. Therefore, our interval between strips is only 1 unit. Then we multiply this with the sum of all the mid-ordinates. Mid-ordinates are the heights at the median of each strip. And when t is 1.5, we had already filled a table such that the value of v will be 1.25. So we are not calculating it again, we just substituting automatically. So we will have 1.25, and we add the next mid is when when the t is 2.5. So 1.25 again, then plus at 3.5 we have 3.25. We proceed at, that was 3.5. So at 4.5 we have 7.25. At 5.5 we have 13.25. 13.25. I'm picking the values right away from the table because we've already filled the table. Then from 13.5, the next mid-ordinate is 21.25. 21.25 plus the last one, that 1.25. That 1.25. So now we can add all these values of the mid-ordinates and we multiply them with 1. Therefore, when we add 1.25 plus 1.25 plus 3.25 plus 7.25 plus 13.5 plus 21.5 plus 31 79.25. This gives us 79.25. So when we multiply this with 1, we will get 79.25 square units. So that's how we apply the mid-ordinate rule. Remember to subscribe to our channel as we continue learning part C of the question. We are taught to find exact area in the region above. Exact area is given by what we call integration. Therefore, we shall integrate for us to get area. We integrate the function. We integrate the function which is t squared minus 40. T squared minus 40 plus 5 from t equals to 1 up to t equals to 8. Let us look at what we get after integrating this. So when we integrate this part, we will have 3 t power 3, and the 3 divides here, then minus 4 t becomes squared, and the 2 divides here such that this becomes now 2 and t becomes squared, plus 5t, and we introduce a constant of integration. Then we are integrating from 1 to 8, from 1 to 8. So now we can get the value of the area after fixing 8, such that we will have 8 cubed out of 3 minus 2 into 8 squared plus 5 into 8 plus a constant of integration, then minus 1 cubed out of 3 minus 2 into 1 squared plus 5 into 1 plus a constant of integration. Therefore, when we use our calculator to get the value of 8 power 3 divided by 3, then minus 2 into 8 squared plus 5 into 8, this gives us 82 and 2/3, then plus a constant of integration. This one minus, when we have 1 cubed divided by 3 minus 2 into 1 squared plus 5 into 1, this one gives us 3 and a third plus the constant of integration. When we subtract, the constant of integration has to cancel one another because it is appearing in both cases. But now we have 82 and 2/3 minus 3 and a third. This gives us 79 and a third. 79 and a third square units. So this is the exact area. You can compare the two values. Exact area is 79 and a third, while the estimated area or the approximated area is 79.25. Now we are told in the last part, part D of the question, calculate the percentage error introduced by using the mid-ordinate rule. Percentage error, part D, percentage error is given by error divided by the exact area, then we multiply by 100. So the error introduced is the difference between the estimated value and the approximated value. The difference between the estimated value or the approximated value and the exact value. Therefore, 79.25 minus 79 and a third, this will give us an error of 0. This will give us, let me subtract 12. 79.25 minus 79 and a third. This will give us 79 and a third, 79.25. So the error is 0. When we subtract 79 and a third minus 79.25, or rather 79 and a quarter, This gives us 0.0833 recurring. Then now when we divide this error with exact value, which is 79 and a third, then we multiply by 100, we're going to get the percentage error in the calculation of the area. This is going to be 0.10504%. So this is the percentage error in the calculation of the area using the mid-ordinate rule. Thank you for following. Subscribe and share.